Hello guys, welcome to the DMS online school. In today's video I want us to revise few questions from this pamphlet here, which says grade 10 ECZ questions 2009 questions paper 1. So we'll start with this one here. Number 1 says all measurable features or properties of objects are called what? So all these measurable features of the object are called physical quantities. So the answer is C here. Then question number 2 says which of the following numbers has 4 significant figures? Okay, first of all you need to understand what significant figures are. So these are numbers that are known to be true with certainty. Okay, so these are numbers that are believed to be correct with certainty in a measurement here. So in this case, when they say which of the following numbers has 4 significant figures, so the keyword is 4 significant figures. Okay, so the correct answer here is actually D here. Okay, so D has 4 significant figures because these zeros after a non-zero digit are significant, these ones here. Okay, then let's do this one, question 3, which says a motorist travels 320 meters at 80 kilometers per hour and then 320 kilometers at 100 kilometers per hour. What is the average speed for the motorist? So what you need to know are the speed are this one quoted in kilometers per hour and this one here 100 kilometers per hour. So average speed in this case, since we are given 2 speeds here, so the average speed, which we can call average speed like this, is going to be equal to speed number 1, which we are given, plus speed number 2, which we are given, sorry, not like this, speed number 2 which we are given, then we'll divide by 2 because in this case they have given us 2 speeds here. So you say equals speed number 1 is this one here, which is 80 kilometers per hour. Okay, then plus speed number 2, it's this one that have given us, which is 100 kilometers per hour. So what we are going to do is to divide by 2 here. All right, so what you are going to do, if you are going to add this one, you get 180, okay, divided by 2, which is going to be actually something like 90. So you have 90 kilometers per hour as your average speed. So your answer is going to be C here. Okay, so let's do the other one. So this other one says a stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 cubic centimeters to 500 cubic centimeters. What is the density of the stone? Okay, so here you must understand that density, which is symbolized by this density, is equal to mass over volume. Okay, so you are told that the mass of the stone is this one, 400. So you just substitute 400 grams there, then over volume. So the volume, you need to know the volume of the stone. So you are told that a stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 to 500 cubic centimeters. What is the density? So meaning the water before the stone was put there, it was at 300, then after the stone was put, it went to 500, meaning the volume of the stone is 200. So you put 200 here centimeter cubed. Then you have to divide actually 200 into 400. You discover that it will go there 2, then you write your gram there, then you write centimeter cubed. Okay, then we proceed, we come to this question, all right, question 5, which says a force acts on a mass of 1 kg producing an acceleration of 1 meter per second square. This force is called what? It is called Newton. It is a Newton. So a Newton is a force which produces an acceleration of 1 meter per second when it acts on a mass of, or on an object of mass 1 kilogram. Then we go to question 6, which says a uniform plank of length 10 centimeters is in equilibrium as shown in the figure below. Okay, we have this uniform plank here, which has the length from here up to there, which is actually 10 centimeters, from somewhere here, from end A here to somewhere here. This is 10 centimeters, as you can see. Then they are telling us to say a force of 100 Newton is applied at point A in the direction shown. What is the weight of the plank? Okay, so there's a force here of 100 being applied here, Newton. Then they're asking us to find the weight of the plank. Remember, the weight of an object always acts through the center. So the weight of the plank is acting through the center, and it is acting downwards here. So this is where the weight is, and this is coming from the topic we call moments. Now, when they say what is the weight of the plank, you need to use the principle of moment here, which says like clockwise moment, like this one, clockwise moment is equal to anti-clockwise moment. Or let me put it in this way so that it matches with what we have. I'm going to say anti-clockwise moment is going to be equal to clockwise moment. So A stands for anti-clockwise and C stands for clockwise, meaning if this thing rotates here, it is undergoing what we call clockwise. If it is going in the opposite of the watch, it is undergoing anti-clockwise rotation. So now you must understand that this clockwise and clockwise moment is given by force times the distance of the force from the pivot. So it is given by force times distance of the force from the pivot. So this distance from here to the center of the pivot here, you need to know it. So meaning this side you need to multiply force times this distance. Let me call it distance 1 here. Then here also we are going also to say the clockwise moment also is given by the force acting here, which is weight times the distance of the weight from the pivot. So this one we'll call it distance 2, so we'll label it like that from there. So meaning it will be equal to weight is the force this side, then times C, which is the distance C to there. Then here we are just going to multiply. Where there's F, substitute, I mean where there's F you put 100 here, then it times. Don't mind about units. Then from here to here is actually, if you count from here, it is from here 1 2 3, so it is a 3. You write 3 here, then equals, then here weight you don't know, you put weight, then times D is from here actually 1 2, so it is actually 2 there. So let me push this one here. So I'll multiply 100 times 3, which will be 300, okay, which will be equal to, then W times 2, it will be like 2W. Remember, we are looking for W weight, so divide by 2 also here by 2, so that 2 goes there, then we'll remain with W. So W is going to be equal to 2 into 300, 150. Now since weight is a force, so we are going to put Newton there as the unit, and you'll see that our answer is going to be C there. Then we move on to question number 7, where I'm going to end from. So question number 7 says a ball of mass 5 kg moves vertically upwards from ground level until it reaches a maximum height of that 4 meters. What is its kinetic energy when it is half way up? Assume gravity to be 10 meters per second square. Okay, so to answer this question here, they want us to find the kinetic energy. So for us to find the kinetic energy, we will just use the potential energy, then half that amount. So you know potential energy is going to be equal to mass times gravity times height, which will be equal to mass. We have this one here, 5 kg times, then we have gravity, acceleration due to gravity, which is 10. We'll put 10 there, then times height. We have been given h is height, which is 4 there. Okay, so when we do the multiplication here, you discover that this will be 4 times 5, which is 20, times 10, which is 200. So it is going to be 200 joules. Now the question is halfway, so meaning we divide this one by half, so it will be 200 divided by 2, which is going to be 100. So you are saying 200 joules by 2, which will give us 100 joules. So you discover that this is 100 joules here, so the answer is C. So this one is our last question. I hope you have learned something from this video. If you have enjoyed it, give it a like and subscribe to my channel. Also, if you are watching it on my TikTok, like and share. Also on Facebook, please consider following the page. Thank you so much. This has been the DMS Online School Teacher.